Using these two triangles and the unit circle, fill in this table. First of all, let's match up the degrees to the radians. So 0 degrees is 0 radians. Pi by 6 radians is 30 degrees. 45 degrees is pi by 4. 60 degrees is pi by 3. Pi by 2 is 90 degrees. 180 degrees is pi. 3 pi by 2 is 270 degrees. And 360 degrees is 2 pi in radians. Now that we have worked those out, let's fill in the table. Let's first of all do the ones using this triangle. Now remember, from the required prior knowledge, we have that these angles here are 45 degrees each. We're only actually interested in one of them, so I'm going to just write in 1. Now if I make this length 1 and this length 1, by Pythagoras' theorem, I have 1 squared plus 1 squared and then the square root of that. That means this length here is root 2. So for 45 degrees, I can work out sine, cos and tan, because sine is equal to the opposite over the hypotenuse. So this one is equal to 1 over root 2, which we often rewrite by rationalizing the denominator as root 2 over 2. Similarly, cosine is equal to the adjacent, 1 over root 2. So we get the same thing, 1 over root 2, which is root 2 over 2. For tan, we get the opposite over the adjacent, so 1 over 1, which is equal to 1. Now let's move on to the equilateral triangle. To use the equilateral triangle, we're going to create a right-angled triangle by dropping down a vertical there, which creates our right-angled triangle, where this angle here is 60 degrees. If my original length of my triangle was 2, then this length is now 1. And again, by Pythagoras, I can do 2 squared minus 1 squared, and I get this length is root 3. Using the 60 degrees, or the pi by 3, sine is equal to the opposite, root 3, over the hypotenuse. So I get root 3 over 2. Cosine is equal to the adjacent over the hypotenuse, so 1 over 2. And tan is equal to the opposite over the adjacent, so root 3 over 1, which is just root 3. I can also use this triangle to do the 30 degrees, because I have halved the 60 degree at here to get 30 degrees. Now I can fill in the column for 30 degrees. For sine, according to 30 degrees, it is the opposite over the hypotenuse, a half. For cos, root 3 over 2. And for tan, the opposite over the adjacent, which is 1 over root 3. And sometimes, or a lot of the time, we will rewrite that by rationalizing it to root 3 over 3. You can see there is a relationship particularly between sine and cosine here, that they are opposites of each other for 30 and 60. Finally, we're going to use the unit circle to do the final ones. 0 is at this point here. That's an angle of 0. Sine, remember, is the y-coordinate, so the y-coordinate there is 0. X is, the x-coordinate is cos, so the x-coordinate there is 1. And tan is the gradient, which is 0. At 90 degrees, the y-coordinate is 1. The x-coordinate is 0. And the gradient is undefined. We cannot calculate tan of 90 degrees. At 180 degrees, the y-coordinate is 0, the x-coordinate is negative 1, and the gradient is 0. At 270 degrees, the y-coordinate is minus 1, the x-coordinate is 0, and the gradient is again undefined. At 360 degrees, we're back to where we started, where the y-coordinate is 0, the x-coordinate is 1, and the gradient is 0. And these are our key exact values. You need to know these or be able to work them out very quickly. You can always use the triangle and the unit circle to find them, but it is probably worth memorizing them because they come up really regularly in the non-calculator paper. There are some patterns. So for example, in this block here, from 0 to 90, sine and cosine are just the opposites of each other. It goes 0, a half, root 2 over 2, root 3 over 2, 1, and then the other way for cosine. Tan is defined to be sine over cosine, so if we do the sine value divided by the cosine value, we get the tan value. You might need to do a little bit of work to see that. And also within sine, there is a pattern that some people like to use. It's a bit of a trick to remember these. This one is the square root of 0 over 2. This one is the square root of 1 over 2. This one is the square root of 2 over 2, the square root of 3 over 2, and this one is the square root of 4 over 2, which is 2 over 2, which is 1. So some people like that little trick to help them remember the sine ones, and then the cosine ones are going in the opposite direction, and tan is sine divided by cosine at any point. As I said, these ones in particular, you need to be able to recognize them quite quickly. We're going to see how we use them quite a lot in exact value calculations for non-calculator trigonometry questions. So you should go away and try and memorize these.